Right, 18B. Went a little bit too far. Okay. Excuse me. So 18B says the middle 95% of residuals should be between which two values? Use this information to give an interval of plausible values for the weekly sales revenue if 5 linear feet are allocated to the store's brand of men's grooming products. So what I'm thinking of, middle 95%, it says up above here, we have a mean of 0 and a standard deviation of 22.92. So mean of 0. Now this 95% is standing out to me because we had something that we talked about called the 68, 95, 99.7 rule. Approximately 68% of the data in a normal approximation will fall within one standard deviation of the mean. Approximately 95% will fall within 2 standard deviations of the mean. And approximately 99.7% of all the data falls within 3 standard deviations of the mean. So if I want 95%, sorry, I want to go out about 2 standard deviations. Well, how big is 1 standard deviation? 92. So I want to go out 2 standard deviations on either side because this right here is approximately 95%. So if 1 standard deviation out is 22.92, how far out is 2 standard deviations? 45.84. So what would it be over here? Yes, negative 45.84. So that answers the first part of the question. It would be between negative 45.84 and a positive 45.84. Now, I will tell you that my answer for this is a couple pennies off what the answer key actually shows because we're using the empirical rule, which is approximately 68%, approximately 95%, approximately 99.7%. We can get more precise than that on the answer key. They did get more precise, but there is nothing wrong in a situation like this of using that empirical rule. If you were asked this question on the AP exam and you used the 68, 95, 99.7 rule, that would be perfectly fine. Okay. So then it says use this information to give an interval of plausible values for the weekly sales revenue if 5 linear feet are allocated to the store's brand of men's grooming products. So this throws back to number, I think it's number 16, part C. Oh, no, number 17, part C, not number 16. Number 17, part C. Because it says that we are in the preceding exercise. So if you look back at 17C, it's right down here. If the store manager were to decide to allocate 5 linear feet of shelf space to the store's brand of men's grooming products, what is the best estimate of the weekly sales revenue? Did anybody calculate this one? You said how much? Like that? Right. Sorry, I'm getting lost on my own answer key here. There we go. On the answer key, they didn't get quite that precise. They took it out only this far, but if you got 1,081 and 34 cents, like I said, I'm always happy with more precise versus less precise. But we're going to grab this number right here, and we are going to add and subtract onto it to get our boundaries. So I would have 1081.34 minus 45.84 and 1081.34 plus 45.84 to find the range. And you get I think it's 1035.50. So I'm doing this in my head. And then up to $11.27.18. There you go. So it'd be in between those two values there. As I go right through it. All right, did you guys have any others that you wanted to talk about or look at?
C.
17C? Absolutely. So the one that we were just looking at? That's okay. 16. 16B. Oh, I see what you're saying. It's A and then part C. One of the company's officers suggests that it would be better to use a matched pairs design instead of a completely randomized design. Explain how you would change your design to accomplish this. So in a matched pairs design, let's see, it says, those who advocate for monetary incentives in a work environment claim that this type of incentive has the greatest appeal because it allows the winners to do what they want with their winnings. Those in favor of tangible incentives argue that money lacks the emotional appeal of, say, a weekend for two at a romantic country inn or elegant hotel, or a week-long trip to Europe. A few years ago, a national tire company, in an effort to improve sales of new line of tires, decided to test which method, offering cash incentives or offering non-cash prizes such as vacations, was more successful in increasing sales. The company had 60 retail sales districts of various sizes across the country and data on the previous sales volume for each district. Okay, so if we're looking at the 60 retail sales districts, in order to do a matched pairs design, you would take the two highest earning districts and match them together. And then you would take the next two highest earning and the next two highest earning until you got all the way to the two lowest earning, and you matched those up. And then you would randomly assign them to either receive the tangible incentive or the monetary incentive. And then you would calculate it from there. But matched pairs, it is possible to do matched pairs with a single person if you're looking at something that they have two of, like 2 hands, 2 feet. So we could compare types of gloves. We could compare types of shoes or types of boots using a matched pair with a single individual. Most of the time when we're doing matched pairs, you're going to take the 2 most alike things that you can find in this larger group and pair them together. And then you'll go to the next 2 most alike things and pair them together. And so on and so forth until you have all of them matched up. Yes?
So I have a question, because it says various sizes. Is it like how much they're earning, or like how many stores there is? Because I think
I think you could probably argue it either way. You could either match them by size, or you could match them on previous sales volume. I would say since you're given both criteria, I would take an argument for either one of those. Let's see. Yeah, the answer key talks about matching districts with the largest sales and the next two largest sales. I think in this situation, that would probably be the safer bet, is to match them up by sales volume. Sales volume and the size of the sales district would probably be fairly consistent. I would think that the largest district would have the largest sales volume, but I would probably mention sales volume here. What else would you guys like to talk about or look at? Yes. Which one? 2.9. All right. So we have probability of infection is 3%, so 0.03. The probability that the repair fails is 14%. And the probability of both occurring together is 1%. So the probability of infection intersect failure, 0.01. We want the probability. What is the probability that the operation is successful for someone who has an operation that is free from infection? So we are starting with the knowledge that they are free from infection. This is a given that situation. So the probability of failure complement, that would be success, given that infection complement. This is what we've been asked to find the probability of. For a given that situation, you have the probability of the intersection, so failure complement, intersect infection complement, divided by the probability of whatever the known thing is. In this case, that would be infection complement. Well, I know the bottom part pretty easily. If the probability of infection is 0.03, then what's the probability of infection complement? 0.97. Remember, an event and its complement always add up to 100%, so it's always going to add up to 1. So now we just need the probability for that numerator there. I'm going to draw a quick picture off to the side so that we understand what we're looking at here. If this is failure and this is infection, I want the probability of failure complement, so outside of the failure bubble, intersecting with infection complement, so outside of the infection bubble. So I want to be outside of both the infection and the failure bubbles. This is the probability that I want for my numerator right there. It's the probability of failure complement intersect infection complement. That's exactly the same thing as the probability of failure union infection complement. If I put failure and infection together, and then I look at the opposite of all of that. So this I can find with what they've given me. I know that the probability of a union is equal to the probability of the first event plus the probability of the second event minus the probability of their intersection. So probability of failure is 0.14, probability of infection is 0.03, probability of both occurring is 0.01, so that's 0.16. So this would be 1 minus 0.16, or that's 0.84. That's my numerator. And if you do 0.84 divided by 0.97, you get like 0.8659999. So it rounds to approximately 0.866. That is all I have time for. I will have time tomorrow during class to answer any other questions that have occurred to you, and or we can play a game. I had the game prepped and ready to go today, but I didn't know if my voice could hold out for that. So if you guys are interested, we can play that game tomorrow, or if you come in and you have specific questions that you really want me to go over first, I am more than happy to do that, and then I will see you guys for your exam on Wednesday.